Hit it!
Deadpool has the ability to regenerate his limbs. Us normals unfortunately can't accomplish the same superheroics with our mere mortal bodies, at least not to the same degree that our favorite merc with a mouth does. But we can get kind of close. I mean, we can regrow skin if we get shallow cuts and fuse together two old broken bones to make one strong, not broken bone that can work just as well as the original. Regrowing a limb is pretty impossible, but that's just for now. Science is tackling this issue and we're getting closer to it every day. Now, if you don't know, the short version of Deadpool's power is that he has a really aggressive form of super cancer. The difference between his type of cancer and the one we usually see is that he has more control over it. Or more scientifically, he has the ability to control his oncogenes and tumor suppressor genes. If you don't know what those are, oncogenes cause cell division, and they're an integral part of the healing process. Tumor suppressor genes, on the other hand, tell the oncogenes when to stop dividing so that you grow back just what you need and nothing else. So when Deadpool loses a limb, his body just tells all those cells to start dividing, and when it grows back, his body just tells them to stop. Boom, new limb. Now, getting back to real life, the most Deadpool-like animal in existence is called the axolotl. It's a salamander, and it has a really weird name, but it uses oncogenes and tumor suppressor genes in the exact same way Deadpool does. And it manages to grow back its limbs in a very similar way, in the sense that they grow back very quickly and very functionally with absolutely no scar tissue. It's just a perfect copy of the limb. And even better, scientists are hopeful that with enough experimentation, they can figure out how to copy this attribute over to human beings. And truthfully, it seems somewhat promising. If you go back far enough, human beings and axolotl actually share an ancestor with the salamander. But before we get too excited, our DNA has changed so much from where we began that the code has become increasingly hard to crack. But we're not going to stop there. In another attempt to solve our Deadpool debacle, researchers at Harvard Medical Center and the Children's Hospital of Boston are testing a gene called Lin28A in mice. The gene is said to increase metabolism and trick the body into thinking it's younger than it actually is. So with the mice, they turned on the gene and surgically removed sections of their ears, toes, and fur, which is pretty gross. But what they found was that the limbs grew back rapidly and perfectly, leading scientists to believe that they may have cracked the code. Unfortunately, not only did Lin28A stop being effective after the mice were past the age of 5 weeks old, but scientists haven't figured out how to make it work with essential organs. For example, you can't cut out a heart and have it regrow in the 1 minute you'd need it. So there were some limitations in the process. And though it's very unlike Deadpool, there are a lot of other researchers out there that are attempting to 3D print organs. Although there aren't any full 3D printed organs being used in humans yet, scientists have printed tissue onto livers and hearts. Because if we can't regrow limbs from inside our own body, modern medicine will still try to regrow them from your cells just outside of your body. We still have a long way to go before humans can start chopping off their own hands to spite their coworkers. But we're beginning to hone in on how to make these dreams a reality. The answers are right at our fingertips. We're hovering around them, and though they might not be perfect at first, with enough time, we will be able to regrow limbs. Whether that be through an intentional gene mutation like Deadpool, or through the use of 3D printed limbs. We're gonna get there. It just takes time.